All right, guys, we're going to start Unit 3 of Notes today. So we're going to go through the atomic structure timeline, what atoms are made out of, and a little bit about the periodic table and how to read that. Okay, way back in history, we have to start at about 400 BC with this guy named Democritus. Now, basically what this guy did is he found a rock laying at the bottom of the mountain and was like, oh, that was a part of that mountain once. So he theorized that all of the matter is kind of made up of tiny things that he called atomos. But keep in mind, this was not based on experimental data, it was just his thoughts and theories. Okay, so basically no major changes over the next 2,000 years. The believed theory at the time was that we were literally made out of the four elements: air, earth, fire, and water. Now this might seem hard to believe, but that's truly what they believed at the time. Throughout this unit, we're going to talk about a lot of dead chemists and their contribution to the atomic model. And this guy's name is John Dalton. He is widely regarded as the father of the atomic model theory. Now each of these scientists have their own model of what they think the atom looks like. And his looks like a pool ball, where he believes the atom was a uniform solid sphere. Okay, now he didn't get everything right, but he had four major postulates, and they're so important I'm actually going to read them to you. Number 1, elements are composed of small, indivisible particles called atoms. Number 2, atoms of the same element are identical, atoms of different elements are different. Number 3, atoms of different elements combine in simple to create a compound. Finally, in a chemical reaction, atoms are rearranged but not changed. So some of these ideas had been floating around for a while, but he was the first one to write them down and really make a record of our thoughts and theories at the time. All right, the next dead chemist we have to talk about is Henry Becquerel. And his contribution to science is that he discovered radioactivity. Okay, so there are actually 3 types of radioactivity: the alpha, beta, and gamma. But in all forms of radiation, we do have a degradation of the nucleus of the atoms. Now, our next dead chemist that we talk about is J.J. Thompson. In 1903, he actually discovered electrons. He had this experiment that you should watch the YouTube video on, the cathode ray tube experiment, where he had a tube and he hooked up a battery to it with electricity pumping through this tube. And what he did is he put a negatively charged plate on the bottom of this electricity-filled tube, and the electricity didn't flow in a circle anymore, it actually flowed upwards. And he thought that was very weird. So his actual conclusion is that electricity must be made out of something negative to be pushed away from that negative plate. And his model of the atom is the Plum Pudding model, which we'll talk about right now. Okay, now I'm sure you don't know what plum pudding is. It's basically just a British dessert that's kind of like a cookie. But in this Plum Pudding model, he theorized that electrons were evenly spread out amongst a pudding of positivity. Now you might be able to understand this better by thinking of it as like a chocolate chip cookie. If electrons are chocolate chips, and the cookie dough would represent the positive pudding. Next is this guy, Ernest Rutherford. I also have a video on his experiment here. Basically what he did is he shot lasers through gold foil, and then kind of had a detection screen around it to see where the laser beam went. Now, he wasn't an idiot. He knew that the laser beam would mostly go right through the gold foil. And surely most of the laser beams did go through the gold foil. But some of them bounced off, and some of them actually bounced backwards. So basically, what he discovered through this is the nucleus. And what he found out about this nucleus is that it is small and very dense, and positively charged. Our next dead chemist to learn about is Niels Bohr. He's one of my favorites. And what he found out is that electrons can really only exist in very specific energy levels. So this is his model of the atom, where the electrons kind of orbit the nucleus. And remember, if you can't see what I mean by the picture, Please follow along with the notes in school. Our next dead chemist to learn about is Erwin Schrodinger. This guy was obsessed with trying to find out where the electrons were located. And what he found out is that we kind of can't find them. We can find the probability of where they will exist, but not find the specific point. Again, he figured out that we couldn't find exactly where electrons were, but each of these dots represent a possibility of where the electrons could be. All right, we did not discover neutrons until actually 1932, which is relatively late compared to all the other discoveries. And they were discovered by James Chadwick. He discovered these neutrons are neutral particles inside the nucleus. So he was the first one to put in that there are protons, neutrons, and electrons into this model. And if you count the little green circles and the little blue circles, they should be the same number. Okay, enough about the history. We are moving on to the structure of atoms. Okay, a lot of you guys misunderstand capitalization, specifically on the periodic table. Like, you might think that CO and CO are the same thing, but cobalt is a metal that forms bright blue solid compounds, where carbon monoxide is a poisonous gas. Okay, so this is a little graphic organizer for you. On top we have the atom, and it is made from the nucleus and the electrons. And inside the nucleus we have protons and neutrons. Protons are positively charged, neutrons don't have a charge, and electrons have a negative charge. Now, you might have heard that the nucleus makes up for most of the atomic mass, and that the atomic number is the same number of protons and electrons, because all atoms are neutral. Now, you might ask, what makes up protons, neutrons, and electrons? And the answer is quarks. There are 6 different kinds of quarks, and 3 quarks make up a proton, and 3 other quarks make up a neutron. Our current model for electrons actually includes an electron cloud where we think the electrons will be. As we said in the Schrodinger model, this is where we will have 90% of probability of finding 1 electron. Okay, and since electrons can only exist in certain energy levels, the lower energy levels are closer to the nucleus. But each of these levels actually has a maximum, and the equation for the maximum number of electrons in each energy level is 2n squared. Okay, we're going to go through a Bohr model diagram here with an example of lithium. So lithium has 3 protons, 4 neutrons, and 3 electrons. And you can see by the red circles that there are 3 protons, and we're representing those 4 neutrons with the blue circles. So if you're drawing this out, you can actually replace that with 3p and 4n in a circle. This represents the nucleus. Now we need to place the electrons around it. But there's actually a maximum number of electrons that can be found in these energy levels. So in the first energy level, we can actually only have 2 electrons. In the second energy level, we can have up to 8 electrons. So we draw our first energy level right here, and we put our 2 electrons in. Then our second energy level can hold up to 8, but we only need 1 more electron because there's only 3 electrons in lithium. Okay, I'm going to go through 2 more examples of these Bohr model diagrams. Okay, we're going to go through magnesium and sulfur. Now, magnesium has 12 protons, 12 neutrons, and 12 electrons. So we want to start in the nucleus and work our way out. So if our first circle here represents the nucleus, we have our 12 protons and 12 neutrons in there. Then we're going to put 12 electrons in these energy levels, but we need to keep in mind their maximum capacities. So level 1 can only hold 2 electrons, level 2 can hold 8, and level 3's maximum is 18 electrons. Now we're going to draw little circles with a negative sign to represent each individual electron. Now those are our first 2 energy levels filled, the first one with 2, the second one with 8. That gets us 10 electrons, but we're not done because magnesium has 12 electrons. So we just kind of put the 2 remaining electrons anywhere in the 3rd energy level. Okay, same thing with sulfur. We're going to start with our protons and neutrons inside the nucleus. And we're going to start with 16 electrons starting in the inner energy level. And of course, our next energy level can hold 8. Now with 2 energy levels filled, that gets us 10 electrons, and we're going until we get to 60. So these are the 2 Bohr model diagrams for magnesium and sulfur. All right, guys, that concludes our part 1 of Unit 3 notes. We are going to have part 2 probably next week. We will have a couple of Schoology assignments over these notes so far, so I don't want to overwhelm you. Let me know if you have any questions or problems, and thanks for watching.